Okay, kids, how's it going? So I'm gonna try to do number 5 on the classwork about the gas laws. Also, hopefully you got my message about, message on Google Classroom about having live sessions tomorrow. We'll work out another problem or two. But hopefully you're starting to get it a little bit. So number 5 has to do with the ideal gas law. Now, I don't have the actual problem in front of me, but I have all the pertinent information. So what you have is, I think it said it behaves ideally. And if it behaves ideally, this is your equation. All right, but there's one problem with the PV equals nRT equation. Well, there's actually a few problems with it, but the one that matters the most is the R value, which is a constant, okay? See, I got my Philly stuff on, even though there's no baseball. I'm very upset by that. Anyway, so the constant has specific units. It's only constant when you have these units, okay? When you have the volume in liters, the pressure value in ATMs or atmospheres, the temperature in Kelvin, and the number of moles. Okay, so we need all of those things. Well, one of them is actually pretty good. We have the pressure in ATM. Okay, now it says we need to find the volume. So the volume is the thing I believe that we are looking for here, right? So we don't know what the volume is. All right, so let's start figuring out what we got. Well, we got the p-value. The p-value is ATM. That's good because it matches the value that's in the constant. All right, but we have kelvins that we need, but I gave you Celsius, and we have grams. All right, well, let's do the temperature first because I think that's the easier of the two. We got a temperature of -30. All right, well, all you have to do to get Celsius to Kelvin is add 273. So that's a pretty simple thing, right? If you add 273 here, all right, what you're going to get is, let me get rid of this V right now. We know that we need to find that. What we're going to get is that the T value is 243 Kelvin, right? Okay, because that's what -30 plus 273 is, or 273 minus 30 if you want to say it that way, right? Now I'll rewrite that we're still looking for the volume. Okay, so now we have two things working for us, right? We got Kelvin in the constant and we got Kelvin in the temperature. The only thing is, if we need to find V, that means we need P, R, T, and N. All right, well, there's only one thing that we don't have, and that's the N value. But fortunately for us, we can get grams into moles. I apologize. There's like a little bit of a glare here, but, you know, I'm trying to do the best I can. All right, so it says 243 here. All right, so let's get our grams into moles. So we're going to take the 250 grams of NH3, and we're going to change that to moles by using our periodic table. So there's a couple things. This is a good little review, right? So we got 250 grams. Uncle Strach likes to call them little baby G's, right? NH3, which is ammonia. And that matters in this problem because 250 grams of NH3 is going to have a different number of moles than 250 grams of, say, like O2 or CO2 or any other gas. Propane, for example. All right, so 250 grams of NH3, and then we're going to have 1 mole of NH3 is 17 point something. I wrote it down earlier. 17.034 grams of NH3, and I'll show you how I set that up. Remember, we spent so much time going grams to moles and grams to moles and grams to moles. Okay, so what we have is a mole is 17.034 grams. We'll cancel out the gram unit. And when we do the division here, it's going to leave us with a number of moles. All right, and that number of moles, I'm just rounding to 3 sig figs, everybody, because I'm pretty much done with all that. We're going to have 14.7 holy moles of NH3. Okay, and that is going to be our N value. Okay, now we have everything that we need to plug into the equation and finish this particular problem. All right, so we have the P, we have the N, right? We got mole, moles matching mole, Kelvins matching Kelvin, ATMs matching ATM, which means our volume is going to come out in the unit liters because that's the only thing left. All right, so algebraically, you can do two things. You can plug in P, plug in N, plug in R, and plug in T, okay, if you want, and then figure it out. Or you could just say, well, PV is equal to nRT, so if I just divide by pressure on both sides, I'm going to have volume is equal to N times R times T divided by P. That's what I think is easier, although when I show you guys some of my answers, sometimes I work them out either way. I might plug it in as the original equation and divide, because that shows you how some of the units cancel. Or I might just rearrange the equation and then plug all the numbers in. I don't care how you do it as long as you get the right answer. You know me, I'm not a sticker of, you've got to do it my way, rah, rah, right? I don't do that. Okay, so let's do V is equal to N times R times T divided by P. So V is, we don't know what V is, but N is going to be 14.7 moles. And I'll show you this kind of in a step-by-step, right? Then our R value is always 0.0821. Units are liters, atmospheres per Kelvin moles. Okay, and our T is 243 K. You know, that was the first time, everybody, I gave you a temperature that was less than 0 Celsius. But it just goes to show you that even though it's less than 0 Celsius, it's still above 0 Kelvin. There is no negative Kelvin temperatures, which is why it's called the absolute temperature scale. And when you get to 0 Kelvin, it's called absolute zero. It's the temperature at which all molecular motion ceases. I think as space has a temperature of about 2.4, 2.5 Kelvin. So, I mean, you're talking about really, 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 really cold temperatures. Okay, so now what? We got our N, right? N, R, T. Now we got to divide by P. Okay, we're going to divide by 1.64 ATM. Now, I'm going to, before I show you the answer, I just want to, again, let you see the whole paper, right? As I drop my answer key. Okay, let's see why the volume comes out in liters the way it does. Because the mole unit here is going to cancel the mole unit there. The Kelvin unit here will cancel the Kelvin unit there. And the ATM and the ATM are going to cancel each other out. Okay, so the only thing left is liters, which happens to be the unit of volume. That's why you have to plug in all of the units the same, okay? That's why you can't plug in millimeters of mercury for your pressure. That's why you can't plug in Celsius for your temperature. That's why you can't plug in grams for your moles, because they're different values, okay? All right, so to get the answer here, we're gonna do 14.7 times 0.0821 times 243, hit equals and divide by 1.64, and kids, we should get a volume somewhere close to, but probably not exactly. You know, that's one of my favorite things to say, besides the fact that you should all be calling me your eminence, remember? The volume is 178.8 liters of gas, ideally. Okay? All right, kids, that's that one. Remember, we have the live session tomorrow. If you have any questions, you can, log on and we'll figure it out. All right? I hope everybody's well. I really wish we were all in class right now, but, that it just wasn't meant to be. Okay? Take care, guys. See you.